To describe the behavior of a function near excluded x values, we need to see the graph of this thing. So to graph this thing by hand, we need our domain. So our domain we get by just finding the zeros of our denominator. We know that our denominator cannot be 0. So x plus 4 cannot equal 0. Subtracting a 4 from both sides, we get x cannot equal negative 4. So our domain is the interval from negative infinity to negative 4, union negative 4 to infinity. And we need our intercepts. For our x-intercepts, we set the numerator equal to 0. So set 9x equal to 0. Divide by 9, and that gives us x equals 0. So that is the point 0, 0. That 0 has a multiplicity of 1 because the exponent on that x is 1. Since that's the origin, we know that that's our y-intercept as well, because the origin lies on the y-axis. Then we need asymptotes. So for horizontal asymptote, we look at the degree of the numerator and denominator. Both have a degree of 1, which means that our horizontal asymptote is y equals the quotient of the leading coefficients. So 9 over 1, which is 9. For vertical asymptotes, we find the zeros of the denominator. So taking x plus 4 and setting that equal to 0, we get x equals negative 4. For that 0 of the denominator, we also want the multiplicity of that. Okay, the multiplicity of that is 1 because the exponent on that factor is 1. Now we're ready to graph this. So for graphing our rational functions, we start off by just plotting the points we know. We know the origin, and we know that we've got the horizontal asymptote at y equals 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we've got the, oops, that's quite right. Got the asymptote up there. We also have our vertical asymptote over at negative 4. 1, 2, 3, 4. So there's our setup of the things that we know, and then we know that we've got to go through this point, and we've got to follow these asymptotes. So we've got to follow our horizontal asymptote. So we're going to follow that, come to this point. And that intercept had a multiplicity of 1, so we cross it like a line. And now that we're below the axis, we have to stay below and follow that vertical asymptote. Okay. Now this vertical asymptote has an odd multiplicity, which means that the behavior on the left side of the asymptote will be different than it is on the right. So on the right of this, we're going down. So on the left, we're going to be going up. And then we come and we follow the horizontal asymptote. So there's the sketch of our graph, and now we can describe the behavior of f near the excluded x value. Now the excluded x value here is negative 4. So to describe the behavior near negative 4, we can do that in either using limit notation or arrow notation. I'll start with limit notation. So we need to describe both sides of this. So we can say the limit as x approaches negative 4. To describe the left side of this, we put a superscript of a negative. So the limit of f of x as x approaches negative 4 from the left. It's going up there on the left, so that's positive infinity. And to describe the right side of negative 4, we do the limit as x approaches negative 4 from the right of f of x. And then, well, on the right of negative 4, we see that our function is going down. And so that limit is negative infinity. So this is our limit notation. To do our arrow notation, we say as, and then this thing in the denominator, or sorry, not denominator, this thing underneath the limit is what goes right here. So as x approaches negative 4 from the left, okay, and then we have f of x approaches the thing that we had over here, infinity. Same thing for the second one, we say as, and then underneath was the x approaches negative 4 from the right. Okay, f of x approaches negative infinity.